Assalamualaikum. Saya akan terangkan part introduction. Oleochemical dihasilkan daripada fats and oil, iaitu daripada animal oils and vegetable oils. Mostly daripada vegetable oil sebab kat Malaysia banyak palm oil. Oleochemical consists of basic oleochemical and derivatives oleochemical. Basic oleochemical contohnya fatty acid, fatty alcohol, methyl ester, glycerol. Dan derivative oleochemical adalah fatty amin, fatty ester, banyak lagi lah. Oleochemical ni digunakan dalam industri, dalam domestic use, food additive and pharmaceutical. Contoh kat sini adalah methyl ester process daripada triglyceride iaitu minyak. Dia akan react dengan methanol dan NaOH akan hasilkan fatty acid, methyl ester dan glycerol. Next, company yang ada dekat Malaysia ni adalah IOI OLEOCHEMICAL Industry. Dia ada dekat Pening dengan Johor. Diorang IOI OLEOCHEMICAL ni menghasilkan ubat menggunakan minyak tu menjadikan ubat. Produk-produk diorang adalah kosmetik dan personal care. Ada soap oil, soap noodles. Dia adalah oils juga. Dia digunakan dalam skincare, dalam hair protection juga pun ada juga.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Anwar Hakim bin Muhammad Mahir and I will continue about 7.2 Thermodynamics Explanation of Processes and Cycles in Oleochemical Industry. For 7.2.1 System, the food, pharmaceutical reaction, fuel production, which is biodiesel and other special chemical production processes are mainly covered by the oleochemical industry. The availability of reliable thermodynamic properties and thermodynamic models for the chemical involved also depends on the essence of the synthesis and the elegance of the process. The application of lipids such as biodiesel, the application of edible, and the production of other major chemical compounds from fatty acid encompasses series of processes such as hydrogenation, fat cleavage, sulfonation, epoxidation, amidation, etoxification, and esterification. Next, I will go to 7.2.2, which is heat transfer theory involved in oleochemical. There's two heat transfer theory, which are firstly conduction, defined as the transfer of heat in physical contact, and the second one is convection, which is a mode of transferring energy between a solid surface and an adjacent moving liquid or gas that involve a combination of the effects of flow and fluid movement. Next, for 7.2.3 system variables, firstly, triglyceride hydrolysis is the process of converting triglycerides into fatty acids and glycerol, which are important processes in the oleochemical industry. Next, exergy analysis methods are based on the second law of thermodynamics and the concept of irreversible entropy production. Third, a process of extraction beta-carotene from palm oil using acetone and ethanol, which involves endothermic processes. Fourth, sterilization with fruits due to the use of closed systems. And lastly, treasure geometry. The main compartment has been divided into three different parts called treasure drum, cylinder bar, and center rod.
Assalamualaikum to Dr. Alif. My name is Shafiq Husna and I will be presenting about the supporting information. So I will start with the palm oil processes. As we know, it will start with full fruit bunches from the plantation will be weighed before it goes to a sterilization process. The full fruit branches, we call it as FFB. so the FFB will go to sterilization process, and then it will go to a threshing process where it will be separated into two, which is the palm fruit and also the empty fruit bunches. So the empty fruit bunches will then be used as fertilizer and also as a fuel for the steam boiler. Okay, so as you know, we need the palm fruit for extraction of oil. So before it goes through the extraction of oil, it will go to a digestion process. So the digestion process is actually a breaking down of oil-bearing cells of the palm oil so that it is easy for us to extract the oil. So then it will go to the extraction of oil, and it will give us three types of product. First is the sludge, and then we have crude palm oil, which is the main product, and we also have the pressed fiber and nuts. So the sludge obviously will going through another treatment, and what we need is actually the crude palm oil. So we'll focus on the crude palm oil first. The crude palm oil then will go to a clarification process to remove any impurities such as water, cell debris, fibrous material, and also non-oily solids. So non-oily solid needs to get rid of it because it makes the oil more viscous. Okay, then it will go to the dilution process where hot water is added, okay, to remove the non-oily solid. Then we'll go to a screening process to screen out the coarse fiber, okay, to remove it. And then it will go to a refining process. Okay, at this process, actually we want to make it a high quality oil. So to ensure we get a high quality oil, the oil will be remove the smell and remove the dark color, or we call it as a bleaching lah. And then it will go to a drying process where we will dry the oil using a vacuum drying so that we can store the oil as a dried oil. Okay, so as the storage, we need to store the oil at 50 degrees Celsius to maintain the oil so that it won't solidification and fractionation. Okay, so I will talk about the pressed fiber and nuts, where as you can see it will be divided into two, fibers and nut. So the fibers will be processed to be used as a fuel in the steam boiler, while the nuts will go to a further process to become a palm kernel oil. Okay, nuts is about triglyceride hydrolysis. Triglyceride hydrolysis is actually a process where the triglyceride is converted into fatty acid and fatty alcohol via thermal hydrolysis. So triglyceride will combine with water to produce fatty acids and fatty alcohols. So they have studied two conditions of thermal triglyceride hydrolysis to ensure which condition is better to be used, because in the old way they use at 100 degrees Celsius of temperature. So but the waste product is becoming a problem, so they have studied two types of condition. The first condition is at 25 degrees Celsius and 1 bar, which is low temperature, or we call it as room temperature. And the second one is 250 degrees Celsius and 50 bar. And it has shown that the 250 degrees Celsius is a thermodynamically feasible reaction. So therefore, triglyceride hydrolysis is now used at 250 degrees Celsius at 50 bar. So next is the sterilization process. So a sterilization process is a process to kill bacteria or more inactivate the microbiome in certain things. So in this palm oil process, we will use steam sterilization. Okay, so because steam sterilization is actually a low cost sterilization, and it is a type of sterilization which is widely used because it is easy to handle and can be depends on. And moreover, the steam sterilization is a non-toxic sterilization method. So a simple principle of steam sterilization in which to ensure the sterilization process occur, it needs the item to be exposed to a direct steam at certain temperature and pressure during a certain time. So steam sterilization have 4 parameters which we need to be focused on. The first one, obviously, the steam. Second is the pressure. Third, the temperature, and also the time. So next is the steam boiler, which produce the steam. So steam boiler is a device which generate power. It uses heat energy which is applied to the water that will produce steam and directly produce pressure. So the water is boiled in the vessel to produce steam. But to ensure that the water boil at high temperature, the vessel must be closed vessel so that there is a pressure from in the vessel. Okay, and last but not least, in the supporting information is about exergy analysis. So exergy analysis is a thermodynamically analysis methodology based on the second thermodynamic laws that offers an alternative and illuminating designation to rationally and consequently analyze and compare processes and systems. So as we know that palm oil plantation use a very high energy, so therefore exergy analysis is utilized. Okay? So the second law states that every isolated system has a normal tendency to degenerate into a more disordered state. So it may direct step to change energy efficiency through a pinch analysis. So pinch analysis is used in exergy analysis. So what is pinch analysis? Pinch analysis is a systematic methodology used by engineers to maximize process plants' energy use. So in order to evaluate energy consumption goals and to define design priority for specific utilities, the engineer may use a pinch analysis. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Syamimi Akmal binti Rahman and I will continue about application in oleochemicals. So people are become more knowledgeable about the environmental and advantages that oleochemicals can offer. So development of renewable bio-based chemical has increased. Therefore, manufacturers are looking at oleochemical as renewable and affordable options in the chemical sourcing industry in order to satisfy the demands of their customer. So these are a few advantages of biolubricants and these make them risen into the industry. So the first application of oleochemicals is biolubricants. Biolubricant is used as a replacement for lubricant refined from petroleum while operating it at high temperature because its chemical and mechanical properties are superior to those present in typical mineral oils. Basically, biolubricants have two reasons why it is risen into the industry. The first is because it has massive worldwide demand. And the second one is because the use of fossil fuels may dry out in future. So we need biolubricants as a replacement for it. Next application is cosmetics. So the pillars of oleochemical supply chains is glycerin, which we common use in production of cosmetics. So glycerin possess anti-aging, skin health and facial cleansing, and also toning properties. It works by drawing water in and forming a barrier on a surface to help retain moisture on our face. Oleochemicals also used in the production of personal care products. Fatty acid and fatty alcohol found in palm oil are used to produce surfactants that used in personal care products such as cleaning, laundry, dishwashing, and household that have surfactants. Surfactants are active agent where it will reduce surface tension of liquid when it is added to water. The water will therefore damp a surface easily and loosen and remove soil. Last but not least, oleochemicals also being used in food industry. Normally, food products use of fatty acid derivative because this derivative is used to ensure proper quality in food system under current condition under which food items are transported over long distance and processed in diverse environments for a long period of time. The example of food derivative are emulsifiers that are added throughout food production. There are several usages of emulsifiers such as margarine, shortening, confectionery products, and also ice cream.
So now I'm going to present the overall conclusion of this project. Oleochemical is a substance produced from oils and fats. The raw material that are utilized to produce oleochemical are from creature and vegetable sources. For example, soybean palm oil, rapeseed, sunflower oil, and creature fats. Oleochemicals are significantly energy assets and intermediates for the creation of oleochemicals around the world. Moreover, there are additionally some thermodynamics which engaged with cycles and patterns of the oleochemical industry. For example, heat transfer theory which engaged with oleochemicals. This is on the ground that heat can be transferred through conduction and convection. There are some applications of the production of oleochemicals which are synthetic lubricants, cosmetic and personal care products, and furthermore food application, which is utilized as a handle nourishments like margarine, shortening, confectionery, and ice cream. Thus, oleochemical industry assumes that a vital part in giving a choice to supplant the non-renewable energy sources on the grounds that the result of oleochemicals are environmental friendly. So I think that's all from us. Thank you.